Hello friends, welcome back to our channel. So today we will see one more concept in our computer networks, that is a distance vector routing algorithm. So routing means transmitting the packets from source to destination and which path we have to follow. So that is least cost distance path should be followed. So we know that there will be a number of routers, okay, and the packets will be transmitted from one router to another router. And here this is a dynamic state routing algorithm. Dynamic routing algorithm. And here every router will maintain routing table. So which fields or which content will be available in this particular routing table, and this routing table consists of the destination hop, so we can call it as a hop or network or router or a system, whatever it may be, and how much distance it required to reach the destination, and what is the next hop, or what is the next system, or what is the next router. And this information will be maintained in each and every router, okay, and this routing information will be shared with all neighboring routers. So this is most important. So whatever the routing information maintained by each and every router, so will be accessed or will be shared among all the neighboring routers. Only the neighboring routers. Now neighboring routers means, so the routers which are having a direct links. Okay, the router which is having the direct link are called as a neighboring routers. And by sharing the routing information with the neighboring routers, the routing table will be periodically changing. So the routing information will be updated periodically. After sharing the routing information with the neighboring routers, the routing table will be keep on updating. So finally this will be repeated until there is no new information is to be exchanged between the routers. Okay, so that's why we call this distance vector routing algorithm as an iterative routing algorithm, and this mainly follows Bellman-Ford equation. In order to calculate the least cost. Path, we'll follow the Bellman-Ford equation. So I'll tell you the equation, and moreover, while solving the problem, you will be understanding what exactly this equation. Right? So, see, the Bellman-Ford equation is dx of y, so where x is a source and y is a destination, so d is a distance, okay, is equal to minimum of v. So here v is nothing but intermediate node. So they obviously in a network one router may not be directly involved with the other router, right? So there might be having some path, okay. For example, if you consider a, b, C and D, so this is the information. So you can see A is not directly connected to C. So if you want to travel or if you want to transmit the packets from A to C, that should be done only in this way. So that means there may be having the intermediate nodes, intermediate hops. So here we represent such intermediate path. So minimum of what we have to do, so cost of x comma v, that means from source to intermediate plus the cost of source to intermediate plus the distance of v to y, the distance of v to y. So this is the distance from node v to destination. This is a cost of node x to v, and this is the distance from x to y, source to destination. So this is the Bellman-Ford equation, and we have to use this equation in order to update the routing table periodically, right? So we will see an example so that you will be understanding perfectly. See, let us take some example. So let it be, the network is like this: A, B, C, D, 4 routers, and the distance from A to B is 5, B to C is 2, C to D is 3, and D to A is 8. Now A will be having a routing table. First one is a destination, distance, and next hop, right? Similarly, B will be also maintaining the same thing. B will also maintain the same thing, right? So the first one will be the destination, distance, and the next hop. Node C will also maintain the same thing. So first one is a destination, distance, and next hop, and router D, it will also maintain the complete information of destination, distance, and next hop. Okay. Now see, destination A to A, B, C, and D. Here there are 4 routers: A, B, C, D. A, B, C, D. A, B, C, D. You know that this is a source. This is a source, and this will be the destination. If source and destination are equal, the distance to be traveled is 0. So obviously A to A is 0. The next hop is none. Okay, and B to B is 0, next hop is none. C to C is 0, next hop is none. D to D is 0, next hop is none. Right? Now, based upon this information, we have to give the complete routing information. Okay. See, A to B, there is a direct link. A to B, the distance is 5, and the next hop is B. And coming to the A to C, there is no direct link. So it may travel through B or it may travel through D. So you can imagine the distance as infinity. Okay, so that means it contains some intermediate nodes, and that can be either from B or D. So simply leave blank. Okay, and here the next node is A. Okay, and C and D. Okay. So because only one node, if only one node, then the next node will also be that same thing, right? Next, A to D. A to D there is a direct link, so 8 distance, and the next one is D. Hope you understood. So there is no direct link from A to C. So if the packet if the packet want to be transmitted from A to C, that can be transmitted through B or D with a different cost. So we don't know which will give the minimum cost. So by observation, we may know that if we want to travel, if the packet want to be transmitted from A to C via B, it requires a less cost, because through D it takes some cost as 11, and if it is B, the cost will be 7. So 7 is the least when compared to the 11. So the packet can be transmitted from A to C with the help of B. But we know that, right? By observation, we can easily know. But the system doesn't know, so that just imagine that we don't know the cost, minimum cost, so simply give the infinity. Similarly, B to A, there is a direct link. So distance is 5 required, and the next one is A. Okay, and B to C, yes, 2 distance and C, and B to D, there is no direct link. It may travel through A or C. So simply you can use infinity and hyphen. Similarly, C to A, no direct link, infinity and hyphen. C to B. So C to B, so 2, distance 2, and the next hop is B. C to D, 3, and next hop is D. And D to A, 8, and D. D to B, there is no direct link, so it should transmit it through the intermediate node, so the cost may be differ, right? And D to C, and 3, and it is C. So for the first iteration, the routing tables will be this one. So A routing table of A, routing table of B, routing table of C, and routing table of D. Now in the second iteration, the routing table of A will be shared among its neighboring routers. Okay, so routing table of A is shared among, you can see what are the neighboring routers of A, B and D. So B and D. And similarly, routing table of B will be shared among A and C. And routing table of C will be shared among B and D. Routing table of D will be shared among A and C. And by sharing that one, so these routing tables will be keep on updating. Okay, now we'll see one by one. So first we'll see routing table of A, which is shared among B and D. Okay, so in this table we got a path for everything except for C. If the packet want to be transmitted from A to C, there is no perfect path. So if the packet wants to be transmitted from A to B, we are having a path. Okay, we don't know whether it is a minimum cost or it is a maximum cost. So that should be done with the help of this one, this equation, right? So let us try this one. Routing table A will be updated. First, you can see this is the destination, this is the distance, and this is the next hop. And this is the routing table of A, updated routing table of A shared with the B. Consider only the distance. Okay, consider only the distance. You can consider only the distance. Need not go with the all other. B distance 5, 0 to infinity. Okay, 5, 0 to infinity. And the destination is A, B, C and D. Now consider the source to destination with the help of intermediate node B. Okay, so here two things we have to consider. One is minimum cost, another one is minimum intermediate nodes. Minimum intermediate nodes. So if we want to transmit the packet from A to B, That can be done through A to D, D to C and C to B, or simply we can transmit from A to B. So we have to consider that there should be a minimum cost as well as the minimum intermediate nodes. So if A wants to transmit the data to B, this is one path, and another path is A to D, D to C and C to B. So in this path also we can transmit the packet from A to B, right? So but here we are having a two intermediate nodes, so we should not consider this one. So this is most important here. So we have to consider the minimum cost as well as the minimum intermediate nodes. So let us check with this one. So A, destination A to A, obviously the distance will be 0, and the next hop will be A itself. Now A to B, okay, so A to B and B to B. So you can see A to B is a cost and distance of B to B. You can see the distance of B to B, and you can add. So which will give A to B cost is 5, and what is the distance from B to B? So B to B, so this is A, this is a B, this is a C and this is a D. So this is a distance, right? So this will be the distance. So here we need to calculate the distance, and this is the cost. Now the cost of A comma B, okay, because we are giving A to B. What's the cost of A comma B? It's a 5, plus what's the distance from B to B? B to B, it's a 0, so it will be 5. Okay, so now simply you can write it here. It is a 5, and the next one is a B. The intermediate node is B, and similarly A to C with the intermediate node B. Now A to B, okay, A to B and B to C, A to B and B to C. See, cost of A comma B plus distance of B to C, which is nothing but cost of AB, which is a 5, and distance of B to C, 2, so it will be 7. So directly we can get 7 with the intermediate node B. Now we can see in the first iteration, so there is no proper path from A to C, but in the second iteration we got some distance with 7. With using the intermediate node B, a packet can be transferred from A to C, right? Next, D. A to D means A to B plus distance of B to D. So A to B is a cost of 5 plus B to D is again infinite. So obviously it will be infinite and hyphen. So the new routing table of A, is A to 0A, AB 5B, C 7B, and D again we are not having a correct path if you want to transmit a packet from A to D. Now again the same routing table will be shared among the next neighboring router D. See, this we got with a B. Now the same routing table should be updated by sharing the information with the next neighboring router D. Okay, now this is a D. Same procedure will be applied for a D also. Okay, consider only the distance. So D distance 8, infinity, 3 and 0. So this is A, B, C and D, and here also A, B, C and D, and this is A. Hope you understood. First, this routing table is shared with B and we are updating the A. Same routing table is updated with the D and we are updating A. Okay, after that we have to combine these two routing tables. See, A to A, obviously the distance is 0 and the next hop is A. Now with respect to D, we have to consider with respect to D. Now A to B. A to B means A to D and plus D to B. That means simply we can say a distance of D to B. So what's the value A to D? 8 plus D to B. It's infinite. So obviously it is infinite. Okay, it is infinite. So you can say it is infinite and hyphen. Now A to C, A to D plus distance of D of C. A to D is 8 plus distance of D to C. D to C is 3, which is 11. So 11 and with respect of D, intermediate node is D. And A to D and A to D. So we know that A to D is a neighbor. So A to D plus distance of D to D. A to D cost is 8 plus D to D cost is 0, which is 8. So it requires 8 with next D. So this is the routing table we got with respect to D. Now we are having two different routing tables. So previously in the first iteration the routing table of A is this one, and after sharing this routing table with the neighboring routers B and D, the tables have been updated in this way. Now combine both and find out the least cost. Consider the least cost. So now you can observe, I'll update this one. Let me update this one. So this is the destination, this is the distance, and this is the next. So A, B, C and D. Consider both the tables. So this is a table A. Okay. So 0 A. If the packet want to transmit it from A to A, if the source and destination is same, the distance it should travel is 0. And if the destination is B, that means if we want to transmit the packet from A to B, so A to B takes a 5 distance and here it takes an infinity distance. So consider the least one. So B 5 and with the intermediate node B, because B is a direct link. Okay. Next, consider C. If we want to transmit the packet from A to C, okay, consider here it requires 7 distance and it requires 11 distance. So with an intermediate node B, with an intermediate node D. Now we have to consider the least one. So 7 will be the least. So the packet can be transmitted from A to C with a distance of 7 through the intermediate node B. And coming to the A to D, if a packet want to be transmitted from A to D, then you can see here there is an infinity and here we are having some 8. So consider the least one. So it requires 8 with a D. So this will be the updated routing table of A. Updated routing table of A. So you can see with your observation, if source and destination is A, it requires 0. And if a packet want to be transferred from A to B, the least distance is 5. Yes. And if the packet want to be transmitted from A to D, the least distance is 8. Okay. So also there is a path from A to B, B to C, C to D. So 5 plus 2, 7 plus 3, 10. So it's a longest path. So here 8. Okay, so we have to consider only A to D. C. And if the packet want to be transmitted from A to C, so through D it is 11, through B it is 7. So what we have to be considered? So 7 with B. So 7 with B. So periodically, time to time, the routing tables will be keep on updated. Now the routing table of router A is this one. So initially the routing table will be created here, and this routing table will be shared among two different, to all its neighbors. So in this network we are having two neighbors B and D. So we have calculated the routing table with respect to B and with the intermediate node D. So in every case we have applied the same thing. So that is a Bellman-Ford equation. So by combining these two routing tables, we are considering only the minimum cost and minimum intermediate nodes. Okay, so this is how we have to consider A, and the same process should be continued for B. So now replacing A with the B data, and the B routing table will be shared among C and A. That means the same calculations, the routing table of B will be updated with intermediate node A here and with intermediate node C here, and both will combine and finally we'll get the complete routing table of B. Similarly C. So routing table of C will be shared among B and D, and we'll combine both and we'll get the updated routing table of C. Okay, and then next D. Again the D routing table will be shared among A and C, and still we are having such type of infinity. Again the same process will be repeated. The updated table will be again shared among the the neighboring routers. So here the neighboring routers means which are the routers or hops which are having the direct link from the source. So we have to repeat the same process and we have to calculate the routing table. So instead of calculating this one directly by observation, we can simply find out the least cost distance, and that should be applied in our competitive exams. We need not explain all these things in the competitive exams, right? So directly by observation we can simply find out the least cost distance. So based upon the distance we are calculating this one. And what is a vector? So this routing table we call it as a vector, right? So the same vector will be shared among the neighboring information, neighboring routers. So it is also called as a distributed algorithm, because the same information will be distributed among the neighboring routers, and also iterative. So the same process will be keep on iterating until there is no new information to be shared. So if here we are having a new information, okay, so there is no correct path, so that's why we are sharing the information to neighboring routers, right? So here we are not having any new information. So there is, for every node we are having the latest, the least distance path. So we can stop here. So this is the distance vector routing algorithm. So the main point is we have to follow this Bellman-Ford equation, and we need to remember that we have to consider only the minimum cost and minimum intermediate nodes. Okay, so I am just stopping here. So you just continue with the same procedure by applying B, sharing B with A and C, C with B and D with A and C, and find out the updated routing tables for remaining three, B, C and D. Now we got A. Calculate and update the routing table for B, C and D, right? So hope you understood, and if you had any problem while updating the routing tables of B, C, D, so feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.